The automotive industry is going through the biggest transformation.
Toyota, a leading car manufacturer with a history rooted in innovation, has recently unveiled a new technology that could potentially revolutionize the automotive industry. This new invention centers on a hydrogen engine, a breakthrough that could potentially outshine other car manufacturers' offerings. With Toyota's reputation for pushing technological boundaries, this new development is certainly worth exploring. And one thing we are certain is that this invention will destroy all other car manufacturers. So let's look at this new invention: the Toyota hydrogen fuel cell-powered car. In the early 1980s, Toyota made significant strides in engine technology, developing compact, lightweight, high-performance, and fuel-efficient engines known as the Lazarus series. These engines, which included the 1GEU and 1SU, showcased Toyota's commitment to superior durability, low vibration, low noise, and maintenance-free design. The Toyota hydrogen fuel cell-powered car is often referred to as the car of the future. This project is basically looking for the production of a car that will be cost-friendly for everyone and not use petroleum as its energy source. The goal of the project is to set a new standard for vehicles in the future, giving the world an affordable, efficient, and environmentally friendly car. Everyone on the team has the opportunity to see how a new project is formed and the excitement and suspense it creates as it is designed and developed. This specific report is interested in mechanical engineers as a whole, especially students who are looking to get into automotive. It's good to get an idea of what it's like to work on a car and see how the theory in school ties in with actual design work. A fuel cell vehicle such as the Toyota FCEV is considered an electric vehicle, although the energy source is fundamentally different. In a fuel cell vehicle, the electric current is produced from a chemical reaction between hydrogen and oxygen, resulting in electricity with water as a byproduct. The electricity is then used to drive the vehicle. In a BEV, the electricity is stored in a battery and then used to drive electric current motors located inside the vehicle. Emission-free driving can be achieved if hydrogen is produced from green energy sources. Toyota Motor Corporation has come a long way since the invention of hydrogen fuel cell power. In the late 90s, Toyota was a company known for its quality and reliability in the automotive industry. It was not until 1997 that Toyota entered into dealing with alternative fuel vehicles and started its project on developing a hydrogen fuel cell-powered vehicle. The concept of a hydrogen fuel cell-powered car was first introduced by the founder of the company, Toyota Soichiro, who stated that automobiles would not be a reality in society if they were to contribute further to pollution. In the coming years, Toyota has expressed a vision of preserving the environment and has addressed global environmental issues as the most important challenge facing humanity. This is the starting point of the project to develop a hydrogen-powered car, which took place in 1997. Toyota has set its long-term goal of realizing a sustainable mobility society. This involves putting an end to environmental pollution caused by automobiles and their complete dependence on oil by developing a system to utilize alternative fuels coming from various energy sources. Toyota has considered many possibilities for alternative fuels such as natural gas, alcohol, and the ultimate environmentally friendly energy source, hydrogen. Making the decision to go with hydrogen due to its high energy efficiency and the energy that can be obtained from any energy source. Toyota has set forth a development plan for the hydrogen fuel cell-powered vehicle, which would be a vehicle of the 21st century. Toyota has clearly done their research and seen that the hydrogen-powered car is the best choice, and by developing such a car, they are going to destroy all other car manufacturers. But how will this engine achieve that? Stay tuned to find out. The significance of the hydrogen car engine invention is very important. It has relieved the world's need for a possible alternative to gasoline engines for automobiles. The importance of the Japanese government-funded project is far more substantial than the goal of finding an alternative to gasoline. The project has called for the construction of a hydrogen society, where Japan has at least a 50% dependence on hydrogen fuel for its energy to lower CO2 emissions and halt global warming. The society aims to not only achieve reduced CO2 emissions and halt the effects of global warming, but also reduce NOx and other polluting emissions from automobile engines while reducing the depletion of natural resources and the recyclability of products. Through the revolutionary development of the hydrogen car engine, many major car companies have jumped on board to help develop and improve the technology for a greater cause. The project and its development provide an energy solution that is environmentally and energy security conscious. Honda, Nissan, Mazda, and other government-sponsored automobile manufacturers have also worked on fuel cell technology. In addition, stationary fuel cell technology is also being developed, and successful large-scale testing shows that it is possible to power an entire house with a hydrogen fuel cell, providing energy security and independence. The ability to provide and store hydrogen provided from renewable energy sources such as solar, wind, and biomass can also greatly reduce the dependence on fossil fuels with stable CO2-free energy and effectively utilize energy resources from production to consumption. Toyota's new power plant is also small and lightweight, which allows for the design of a car with ample interior space while still maintaining high levels of both performance and safety. The power plant is extremely quiet in operation, does not produce any noxious gases, and its high energy efficiency will enable the vehicle to travel over 500 km on a single fill-up. These unrivaled environmental performances and energy efficiency levels are expected to surpass those of other hybrid electric vehicles and gasoline-powered vehicles. With their development of an efficient hydrogen-powered engine, Toyota has certainly made a bold statement in their commitment to revolutionize vehicle propulsion and achieve a sustainable future for personal mobility. Toyota's engine technology is expected to be the most advanced in the fuel cell industry. The new power plant consists of a compact, high-efficiency monotube fuel cell stack and a new ultra-high output, high-efficiency electric drive motor. This system will achieve an efficiency level that is more than twice that of a traditional internal combustion engine. The 40 kilowatts fuel cell stack realizes a high output in relation to its size, which enables it to start at sub-zero temperatures. A regenerative system further improves energy efficiency. The newly developed ultra-high output electric drive motor boasts an efficiency level that is among the highest in the world. The drive motor and fuel cell together form the hybrid unit, which is expected to deliver performance equal to that of a 2.4L internal combustion engine at a fuel efficiency exceeding 20 kml with a 0 to 100 km/h acceleration time of about 10 seconds. With the use of an electric motor, it is evident that power is not going to be the problem. To this end, Cadiz commented that Toyota has a greater advantage because a fuel cell has a higher power density and higher efficiency than a conventional internal engine using spark ignition combined with a mechanical transmission. The FCV will have about the same acceleration and driving performance as a Toyota Crown with a 2-liter engine. Initially, Toyota put a hybrid system fuel cell into the car, famed as the GTV Hydrogen, to provide more practical data from road tests. Then, later in 2003, using the same platform, they built a pure fuel cell car named the Toyota FCA-V4. The FCH-V4 managed to achieve a mammoth 830 km test distance on a single tank of hydrogen, as verified in May 2003, cutting time and lowering costs for regular fill-ups to make a real-world alternative for the customers. Toyota took the revolutionary step to design and build a hydrogen-powered engine used in the Japanese government's official vehicle, GVT, known as an FCV, fuel cell vehicle, in 2002, leaving conventional petrol engines and electric motors behind. According to Derek Cadiz, the ex-chief technology officer of Jaguar Racing, motorsports is used to driving technology extremely hard, and Toyota did just that. They came up with a highly advanced chassis with a very lightweight hydrogen fuel cell stack that managed to combine both the fuel cell and ultracapacitors in one unit, and ultracapacitors to provide power for acceleration. This is unlike anything that has been seen before. And even though Toyota had given it a go back then, they are here to refine their idea and make it a reality. But what more is there to this car? Stick around to find out. Hydrogen fuel cells have been in development for nearly 150 years, with the first conceptual ideas being thought up in 1820 by a Welsh scientist named Sir William Robert Grove. It wasn't until the 1960s that NASA decided to use a fuel cell to power the Apollo spacecraft on its mission to the Moon. Developed by Francis Thomas Bacon, the cell was an alkaline fuel cell, similar to the PEFC that Toyota is developing today. The biggest difference is the use of pure hydrogen and oxygen stored in separate tanks compared to an air filter being used by the alkaline fuel cell. The greatest advancement in the development of hydrogen fuel cells has been the reduction in the size of the unit itself. Early fuel cells were so large that they had to be transported by tractor-trailer, making them impossible for widespread use. Changes have been made to the fuel cell stack, which has greatly reduced the size of the unit. Early stacks were a stack of fuel cells and radiators to remove excess heat, whereas the modern stack has a greatly increased power-to-size ratio and a built-in system that cools the cells with the water produced in the electrochemical reaction. This, of course, means that there is development in the fuel cell itself and the method of attaining hydrogen. Throughout the history of the fuel cell, additional technologies must be developed to keep up with the rapid changes in cell technology. In 2003, at the Frankfurt Motor Show, Toyota demonstrated its relentless commitment to hydrogen power by displaying a turbocharged Corolla with a smaller, lighter, high-performance fuel cell system that was twice as powerful as its original fuel cell stack. The Toyota FCHV did one better by using a standard production ECU and achieving power outputs of 90 kilowatts, generating a top speed of 155 kilometers per h. Where it really triumphed, though, was in the field testing. In 2002, a Toyota FCHV was able to reach the 5,700-meter summit of Mount Fuji, the highest peak reached by a fuel cell vehicle to this day. The FCHVC advanced walkthrough monologue, where the fuel cell stack was mounted beneath the floor for an even lower center of gravity, and further a revolutionary electric 4WD system, with in-wheel motors and independent right and left motor control, made this vehicle the highest performance fuel cell vehicle yet to date, reaching power outputs of 120 kilowatts. The popular reason for Toyota developing higher performance fuel cell vehicles has been to effectively demonstrate the capabilities of a fuel cell powertrain, to be able to truly compete in today's market, and also to stimulate and foster further fuel cell technology development in the automotive industry. This has been proven at various times through announcements of million-dollar-plus prize money. Toyota is leading the race, and the game has never been so exciting. Further progress, or what can be deemed a far more significant step, occurred in 1992 with the establishment of the in-house PEV project. It was within this stage that the first Toyota-made electric vehicle was developed, the widely known RAV4 EV. The purpose was to research to understand the social infrastructure and implications for a society based on EV use. During the late 1990s, Toyota also committed to the R&D of a hybrid system, and consequently, in 1997, the Coaster HEV, hybrid electric vehicle, was created, featuring the Toyota Hybrid System, THS, and an improvement from the original system installed in the RAV4. Toyota's hydrogen and electric technology has developed and evolved as a result of the necessity to find an alternative renewable fuel source for the internal combustion engine. This has occurred through sequential stages, each targeted towards a goal, be it independence from oil, reducing vehicle emissions, or the creation of a sustainable, environmentally friendly vehicle. As early as 1971, the GTV electric vehicle was developed as a joint project with Tokyo Energy and Industry, comprising a Celica with a nickel-cadmium battery-based EV system. Toyota recently signed an MOU with Ford to conduct collaborative research on developing an advanced fuel cell hybrid system and its purposeful use in SUVs and light trucks. This initiative parallels a similar research agreement that Toyota has with the National Renewable Energy Laboratory of the U.S. Department of Energy to advance fuel cell vehicle research and development. The overall goal of these efforts is to accelerate the development and enhancement of hydrogen and fuel cell vehicle technologies and their successful commercialization in the future. This is consistent with the Bush administration's Hydrogen Fuel Initiative, which aims to accelerate the transition to hydrogen-powered fuel cells and bring the benefits of hydrogen fuel cell technology to American consumers and businesses, reducing the dependence on imported oil and increasing energy efficiency while reducing greenhouse gas emissions. So from the many Toyota fuel cell vehicles developed over the years to the recent development of its commercial-grade fuel cell hybrid system for SUVs and light trucks, these technologies have always been driven by the singular aim to help preserve the global environment and further realize a near-future society with a sustainable energy cycle using hydrogen. With the development of all these different types of fuel cell vehicles and hydrogen-driven engine systems, Toyota will continue to be known as the company for hydrogen and fuel cell vehicle research and development, which will soon become its most important and significant venture. In this technological era, cars are seen as an essential part of everyday commutes. Cars are becoming increasingly affordable and economical to run, and due to a shortage of non-renewable resources in this day and age, Toyota has come up with a way to break away from the traditional internal combustion engine-powered cars to reduce emissions of gasoline and produce a car that runs using a fuel cell and produces zero emissions. According to Toyota, this approach is based on using hydrogen as a fuel for transportation. This essentially means that a hydrogen-powered car only emits water. This car will have a huge impact on the environment as there will be less pollution, and it will also use some excellent familiar technologies, including the famous Toyota hybrid system. This is a fairly new system that is seen as a stepping stone en route to the development of the ultimate eco-car, a hydrogen-fueled vehicle. The hybrid system has already been a huge success, improving fuel efficiency and reducing emissions. The fuel cell here is essentially the engine that drives the car. It is highly fuel efficient and emits no greenhouse gases due to hydrogen being oxidized, and in turn, causing an electrochemical reaction, resulting in electric power to drive the vehicle. This power is comparable to that of an engine powered by gas, and Toyota aims to make the fuel cell sufficiently powerful to meet customer needs in both driving performance and range. How Toyota's invention compares to existing technologies. After assessing and understanding exactly the concept that lies behind Toyota's invention, it is clear that the company's new technology has the potential to revolutionize the car and possibly even the power industry. The new technology will not just provide a source of power for a new cleaner car. It is aiming to use the car as a source of power for a home or even the power grid. This differs from current electric cars, which can only draw power from the grid. Toyota's current technology can be viewed as a self-sufficient system, and as fossil fuel reserves become scarce and prices escalate, the ability to generate power from the car will be an attractive and possibly cheaper option. The ability to generate power from the car will be achieved through a newly developed method of converting chemical energy in fuel to electrical energy at a higher voltage. This will involve the development of an onboard electrical system with higher fuel efficiency than internal combustion engines and emissions levels lower than fuel cell vehicles. In terms of existing technology and competitors, the idea of a self-sufficient car that can provide power to a home is completely unique. Current electric cars and hybrids are connected to the power grid, and the thought of a car providing power to a home or any kind of building infrastructure is a foreign concept. Energy concerns behind electric cars and hybrids are also a limiting factor for their sale. With electric cars, the power grid that they are drawing power from is still largely generated from fossil fuels, while hybrids have a dual energy source. The fact remains that modern society has been built up using fossil fuels, and it is becoming harder and harder to make a full transition to renewable energy sources. This is the issue that leaves both electric cars and hybrids with a limited lifespan, with electric cars losing their edge on emissions and hybrids being dependent on the existence of cheap fuel. A time may come when power from the grid is not a feasible or cost-effective solution, and it may be that Toyota's technology is the contingency plan. In the post-World War II era, Toyota developed an innovative method of production in the form of the Toyota Production System, TPS, and grew at a rapid rate as it captured market share both domestically and internationally. TPS was groundbreaking in its integration of an evolving set of tools and principles to improve operational efficiencies. Key distinguishing aspects of TPS as an innovative system were its focus on jidoka, and just-in-time production. Jidica involves the concept of automation with a human touch, in that machines stop when a problem occurs, preventing defective items from being produced, whereas just-in-time production describes the allocation of production items so that they are only created in the necessary quantities and at the necessary times. Influence from these two events of innovation is very apparent in the current Toyota as well as the wider automotive industry, and may have contributed to the current climate of invention and Toyota's confidence to undertake a project such as the development of PMVs and the I-Road. The following section of this essay will focus on a comparison between Toyota and other automakers in the area of innovation. It will do this by exploring both the timing of particular inventions relative to technological and automotive industry development at the time and the specific innovative technologies employed. The intention is not to provide an extensive history and analysis for each automaker, but rather to provide a concise overview and lay the groundwork for a comparison with Toyota's new invention. First and foremost, the new invention by Toyota will disrupt the market by offering a low-cost, fuel-efficient vehicle. Before this, hybrid vehicles and regular fuel vehicles were the main targets for most consumers. Now, Toyota offers a clean-burning, ultra-compact vehicle that is priced cheaper than any gasoline-electric hybrid vehicle on the market today. According to Toyota, the estimated price of the new invention will be anywhere from $7,000 to $8,000. The fuel savings offered by this vehicle compared to traditional compact vehicles on the market today will pay for the price of the vehicle in just a few years. The new invention will be highly beneficial to lower-income families and people in third-world countries. Not only does the price make this vehicle an attractive option, but the fuel mileage is incomparable to any gasoline or electric vehicle. At 104 mpg, this vehicle more than doubles the fuel mileage of today's current gasoline vehicles. The high cost of fuel is a major issue in today's society, and a vehicle with high fuel mileage at a low cost is very desirable. Beyond the pricing and fuel savings, this new vehicle provides an alternative solution to mini-compact cars and electric vehicles. With more space, power, and features, this vehicle is a better purchase for consumers who desire a compact car for fuel savings, but were turned off by the lack of space and power in today's compact vehicles. A better product at a cheaper price is always a major selling point and will compete with existing compact cars and hybrid vehicles in today's market. Impact on the industry. Toyota has been a giant in fuel-based vehicles since it started its operation. They are the leader in hybrid technology, with the Prius being the best seller. With the world moving towards depleting oil resources and environmental concerns, the face of the automobile industry is changing, with a lot of emphasis on clean and green automobiles. With its vast resources in finance and technology and a wealth of knowledge in regional markets, Toyota is trying to steer the industry toward hydrogen-based vehicles. Though, as is common with almost all new technologies, it carries an inherent risk. The risk of using a new technology is plausible failure and higher investment costs. Concerns in the automobile industry, whether they are the result of new technology or looming economic threats, always seem to center on which companies will survive the ensuing shakeout and what the industry will look like when the dust settles. The current shakeout taking place in the global automobile industry is of epic proportions. The industry is careening toward an uncertain future as the convergence of disruptive technologies, new business models, and shifting regulatory environments permanently alters the landscape. Toyota also predicts a series of reactions from oil and electricity companies. The growing trend towards environmentally friendly fuel alternatives and the increasing gap in MPG efficiency between hybrid vehicles and traditional combustion engines will likely see a higher demand for green fuels and an increase in research and development of alternative energy sources for cars. This can only further emphasize the benefits of owning a hybrid vehicle and create a wider spread of infrastructure for the fueling of such vehicles. With all current major manufacturers having invested interests in both electric and combustion engine vehicle types, it is also expected that the costs and margins of hybrid vehicles will mirror Toyota's analysis of its competitors. Once the implications of Toyota's new invention have been determined, a plausible step would be to forecast how competitors will react. It can be assumed that a technology that disrupts the current market or business model will raise a response from those who are at risk. There's a consensus amongst the executive team at Toyota on the likely reactions to the Prius and current market trends in hybrid electric vehicles. It can be predicted that price competition will occur with regard to the various low-cost hybrid vehicles that are currently available. This, it is hoped, will in turn lead to a larger market for used hybrid vehicles, thus a swing away from traditional combustion engines and towards hybrid technologies. One major market change is forecasted by Creeth and Che, 2002, who predict a decrease in fuel sales in developing countries due to more stringent emissions restrictions in the future. This is a long-term prediction that will begin with a change in fuel type for vehicles, and eventually a change in vehicle technology. Although it is hard to gauge the specific effects of this on the automotive industry, such changes would either force vehicle manufacturers to adapt their current technology or result in a huge market for new technologies. This new market would likely see new vehicle technologies becoming more advanced in an attempt to provide a solution to the real or perceived relative risks and unknown future costs of current and future environmental regulations. Emission standards and requirements are only likely to become more stringent until the greater goal of preserving the environment is reached. Therefore, it can be said in general that the more stringent the requirements for vehicle emissions, the higher the demand for the development of new vehicle technologies. This trend would be hugely beneficial for Toyota, which would have a head start on other manufacturers with this new technology. On the whole, the future for the automotive industry with regard to the technology of Toyota's new invention is a positive one. The intricate details of the invention, from the engine modifications to the fuel source, are steps in the right direction for the industry in general. In terms of immediate changes due to this invention, both Dargay, 2007, and Fulton, 2001, predict a decrease in oil and fuel consumption, which reflects a shrinking of the global market share for petroleum and an increase in the market share of alternative fuel sources ranging from nuclear energy to renewable energy resources. Although Toyota's invention involves the hybridization of cars and superior fuel cells, it is a stepping stone for the development of alternative fuel vehicles. Vision for the future green research and development towards sustainable mobility have often been considered by several car manufacturers. However, they have often been scrapped due to the current global economic downturn. According to Toyota, the global popularity of conventional cars has created serious issues such as climate change and peak oil that will impact global society in the future. Based on the assumption that technological innovation can change the world, Toyota has developed the Prius plug-in hybrid and the PHV system with the aim of creating a sustainable society in which people can move freely, live comfortably, and coexist with the environment. The hybrid technology of cars, when it was first conceptualized, was seen as a noble attempt. But the limitations of the electric engine and the almost ridiculous costs of this technology, when compared to burgeoning gasoline engine tech, saw it as something of a fringe research project for most companies. Suffice to say, some of the most innovative car technology in the last 20 years has come out of the push by car manufacturers to make a more fuel-efficient car, and Toyota has in many ways been leading this charge, with competitors playing continual catch-up. Toyota, of course, would never have attempted to invest so much resources into an all-electric engine had their initial Prius prototype not shown so much promise. Being a cornerstone car in terms of environmentally friendly tech and high mileage for the dollar, it makes sense that Toyota would continue to push for higher fuel efficiency. The Tesla-like decision to pioneer their new tech with a sports car is a good idea as well. It's a common trope in auto manufacturing, but it's no less true that the sports car market has widespread implications for the direction of car tech, with more fuel-efficient technologies eventually finding their way into bigger market segments. Step one of Tesla's master plan was always going to be the least profitable, and Toyota's experiences in the niche luxury car market will undoubtedly make for an easier time. Toyota has great ambitions with the hybrid Synergy drive, aiming to bring change to the world by cutting the amount of CO2 emissions that its vehicles produce in half. This is no small task, but with the technology moving towards being adopted as a global standard, and with pressure from government and environmental organizations, Toyota has a real chance to achieve this goal. The impact of being successful in this area would be industry-changing, as it would force other car manufacturers to follow suit with similar technologies to remain competitive and meet the standards set by Toyota. The result could be a revolution in the way cars are powered, with a shift from the traditional internal combustion engine to electric and fuel cell propulsion. That's all for today. See you in the next one.